multiplication of fractions, the thing we want to do here is we want to look at what does it mean to be a fraction and what does it mean to be a multiplication, and use those ideas to motivate why we should do it a certain way. So before I get to fractions, let's just think back on what multiplication means. So models for multiplication that we had before, the big ones were 1, repeated addition. 2 was an idea called groups of. And 3 was the idea of an area, where we consider area base times height. So if I were to ask to multiply 3 times 4, oops. Repeated addition is pretty straightforward. This says you want to add 3 groups of 4. So I have a 4 and another 4 and another 4. And 4 plus 4 is 8, plus 4 is 12. So that's model number 1 of what it means to multiply. Model number 2 is to just replace the symbol multiply with the phrase groups of. What does it mean to have 3 groups of 4? Okay, well, I draw a group of 4, and then I draw another group of 4, and I draw a third group of 4, and I can see I have a 3 by 4 grid, and there are 12 things there. So when we combine and count 3 groups of 4, we should get 12, which is similar to the addition problem. Right? There's 1 group of 4, 2 groups of 4, 3 groups of 4. The third method is a similar picture to the second one, and that's to draw an area where you have a base that measures 1, 2, 3, 4, and you from there make a height perpendicular, right angle, up 1, 2, 3. So then this region right here, to the best of my artistic ability today, is my 3 by 4 grid, and the area within that grid. Come on, my pen is refusing to work. Why? There we go. So this area in here is 12, because I have a base of 3 with a, oh, I did it backwards, didn't I? I did a base of 4 times a height of 3. And I can see there are 12 squares in here, and I meant those to be squares. So we'll try those with fractions, those ideas. So those are models. What does multiplication mean? Multiplication means one of these 3 things. What does a fraction mean? Well, a standard definition for a fraction is equal part of a whole. So with the repeated addition, it gets a little weird. Like if somebody said, take 1/2 times 1/3. So here I can definitely take 3 4s and add them, but how do I add 1/2 of a third? So as far as repeated addition, I'm not really sure what that means here. So sometimes that interpretation's rough. If instead somebody said 4 times 1/3, well, that would just mean take 1/3 and write down 4 of them and add them up. So if the leading number is a whole number, the repeated addition does work just fine. But if the leading number is not a whole number, then it's hard to interpret what that really means. So I'm going to say I don't really like repeated addition, multiplication for fractions because it's hard to interpret. Groups of. So this was method number 1, not exactly productive. Method number 2, groups of. 1/2 times 1/3 means 1/2 groups of 1/3. Well, I can definitely think of what it means to be half of a group. Like if somebody said, what's half of 12? I could come over here and say, well, here's half of 12 right there, right? Half of 12. And then I certainly know what 1/3 looks like, okay? So for this one right here, for me to figure it out, I want to find what is a half a group of 1/3. So what is 1/2 of a group of 1/3? Whoa, not a very good 3 there. Before I can answer what half of it is, I got to show the 1/3. So I'm pretty good at drawing a third. I'm going to use my square cake method. That's my square. And then I want 1/3 of that. So I have to estimate where my thirds fall. It's not too bad. And then I want one of those thirds. So maybe I'm going to pick, let's stick with green here. This is the third I want. So that's what a third looks like. And I know how to cut things in half. I would choose to cut it this way. So I want half of that, which would just be this piece right here. So this thing right here is 1/2 of 1/3. Next question, I've identified that region right there. To finish this off, I need to identify what part of the whole is that. What part of the whole do I have? Well, I can see my whole has 6 pieces and I have one of them. So it looks like my answer is 1/2 of 1/3 is 1/6. Coincidentally, 1 times 1 is 1 and 2 times 3 is 6. Does that always work like that? We'll look at another example to double check. So again, what am I trying to do here? I'm trying to figure out, how do I multiply fractions? If I know what it means to multiply, and I know what a fraction is. So I'm just going to pick another pair of fractions and try again. I think I'm going to try the area model this time. But groups of works all the time. Let's try 3/5 times, how about 1/4? And I'm going to use the area model. And so the area model, I'm going to have a base by a height. So I'm just going to set up a little grid for myself to draw on here. So this is going to be my baseline there. And this is going to be my height straight up from that. And to identify 3/5 for my base, I first have to identify, what does 1 look like? So I'm going to measure out here. Let's see, how about holding up a piece of paper to my screen to measure both directions right. So I'm going to make 1 right there. And then vertically, that would put 1 right here. So this region right here is 1 whole, because it's 1 by 1. So because we're working with fractions, we need to know what part of a whole is. We can only know what the part is if we know what the whole is. So next, I'm going to measure out my 3/5. So if that's 1 whole, I have to figure out what fifths look like here. And I'm going to guess that this is about 1/5, 2/5, 3/5, 4/5. And then 1 whole would be 5/5. So I want this one right here is my 3/5. fifths. 1/4, that's going to go vertical, my height. So that's about a half. So these would be quarters. Not the best. Let's try that again. There, maybe it's better. So this one right here is my 1/4 from the bottom. And I'm trying to identify an area that has this base and height. So that would be this area right here. So that's my answer right there. Question, what part of a hole is that? Well, I know this bigger region is a hole. So to figure this out, I'm going to actually draw in the rest of my fifths. So I'm going to draw my 1/5 vertically. I'm going to draw my 2/5. I'm going to draw my 3/5 and my 4/5. So I've split this into fifths in that direction. I'm going to split into fourths in this direction. Okay, now when I look at this grid, I'm just going to make a note that one hole has 5 by 4 pieces in it. So there's 20 pieces in a hole. My area has 1, 2, 3 of those pieces. So that tells me that 3/5 times 1/4, according to the idea of area and part of a whole, has to be 3/20. Coincidentally, like before, 3 times 1 is 3, and 5 times 4 is 20. So the point of this is to say, well, what does multiplication mean? Based on what multiplication means, that should eventually show us how you have to multiply fractions. So these two examples seem to indicate that to multiply fractions, so we're developing a fraction multiplication algorithm. And an algorithm is a process, a set of steps you follow. And the steps seem to be multiply the numerators to get the new numerator. And multiply the denominators to get the new denominator. In addition to the steps to follow, we have our arrow way of doing it too now. So we can illustrate to justify why the answer ought to be that. And now we have a process to get that answer for other numbers.